This is the Military and Aerospace Electronics Report. I'm John Keller, reporting this week from the SPIE's Defense Security and Sensing Symposium here in Orlando. This show draws thousands of attendees every year and indeed is one of the largest unclassified aerospace and defense electro-optic shows in the world. We're going to be talking to all kinds of exhibitors here at the SPIE show who are working on applications from everywhere from heat removal and also to harvesting heat for power for applications like sensors in aircraft engines that help with predictive maintenance. We're also going to talk to people who are bundling fiber optics together to help channel light to keep waste light to a minimum in avionics applications and handheld electronics applications. Let's take a closer look inside. Nextream in Durham, North Carolina is a company that started out life specializing in cooling. But the interesting thing that they do is they're able to generate electrical power from waste heat. This is Dave Keister, Vice President of Engineering for Nextream. Could you tell us a little bit about how you're able to generate power from waste heat, how it works, the principle?
Well, the principle behind this is what we call the Seebeck effect. In certain materials, semiconductor devices will produce current when a thermal gradient is introduced into the material. So heat passes through the device and it creates an electrical current at a conditional voltage. What we've done is we've created a device, we've placed it inside this assembly where we have the thin film device between this plate and the base of this heat sink, so that the heat sink allows for a continuous flow of heat. And then when we place that on the heat sink, you will induce a temperature differential across the thermoelectric, which then produces the current flow. What we've done here is to include an electrical board that provides voltage conditioning so that we can produce a constant output voltage of either 3.3, 4.1, or 5 volts. After about 30 seconds, we'll turn on a little blue LED on the board. So that's an onboard LED just to show the functionality of the device. In addition to that, we've allowed for compatibility with the Texas Instruments EZ430 system, and what this is has an onboard temperature sensor and a transmitter which will communicate to a wireless node which is in a laptop computer underneath this table. So if we place this onto the hot plate and give it a few seconds to charge up the capacitor on there, it will bootstrap the circuit and start to transmit the information to the wireless node.
So where's that power going to go that's generated from waste heat? Nextream is already in discussions with sensors manufacturers who are thinking about applications like predictive maintenance for aircraft engines, plumbing, devices. It almost seems limitless. One problem in today's avionics, handheld electronics, and those types of things are the light that emanates from the displays. Sometimes it can make anyone a target at night, even with someone with inexpensive night vision goggles. What Sean is doing is they're creating glass that only has a directional light source. Why don't we take a look?
What we're showing here is a ruggedized vehicle display. And what you can see here is we've incorporated what we call a defined viewing angle fiber optic faceplate. So this cover glass is actually made up of millions of individual fiber optic elements that have been fused together. And what we can do with that is use the properties of those fiber optics to control the viewing angle coming out of the display. So it cuts down on the light signature in the vehicle displays to a very defined angle. This same technology can be utilized in handheld displays for soldier systems and also incorporated into the new digital displays being used in avionics displays.
So the SPIE show, it's one of a kind. Last year in Orlando, however. Next year, the last week in April, it's going to be in Baltimore at a new site. For the Military and Aerospace Electronics Report,